Alright, systems of inequalities are when you have less than and greater thans. If I'm going to graph this first graph, you begin at the 1, positive, and that's like a negative 1x, which means I'm going to go down 1 over 1. Negative means down 1, and it's over 1 because negative 1 is negative 1 over 1. Now, it is a dotted line because it's just a less than sign. So we got a dotted line, and that is less than. So less than means bottom, and the bottom is right there. Now, lightly shade. If you do it dark, it gets really ugly because you have multiple graphs. The next one, y is greater than or equal to negative 2. So put a dot at negative 2 on the y-axis. What values are greater than negative 2? Well, we need to make a solid line. It's a horizontal line in this situation. And we want values greater than or equal to negative 2. By the way, solid line, because or equal to. Greater than would be the top side. So my answer is where these two overlap. And you would darken or obviously shade that area. It's kind of like claiming the answer. If you don't shade it darker, I don't know what you actually are claiming as the answer. It's kind of like boxing or circling your answer. So darken in the spot that is double shaded. Again, a less than or greater than sign is dotted. An or equal to sign is solid. Shade the appropriate sides. Number 2, x is greater than negative 3. So start at negative 3 on the x. And an x value graph is vertical. Because it's just greater than, it's dotted. Now, that's that one. If it's greater than, which side of this line is the greater side? It's the right. These have bigger values. Remember, lightly shade. The second equation is not ready quite yet, so we have to rewrite it here and make it into a better form. So to get y by itself, our first step, this is the second equation, is going to be to add the 3x over. Next, I want to get the y without the negative in front. So to undo a negative, you divide by negative 1. So you end up with y. Now when you divide by a negative, the sign flips. Becomes a greater than or equal to. 3 divided by negative 1 is negative 3. 1 divided by negative 1 is negative 1. There's my graph. Which means I start at negative 1. And what am I going to do? I am going to go down 1, 2, 3, and over 1. And it is dotted, no, it's solid line. It kind of goes a little far. And which side of this line is the greater side? It's actually over here. Now, your answer is where they both overlap. Now, would this little area right here count? Is that true for both? No, it's only the area to the right of the green line and above the red line. Next, this one has 3 equations. X is less than 2, so put a dot at 2. Sorry, x is less than 1, so put a dot at 1 for x. It's a less than, so it's dotted. Less than, well, the smaller side of an x is this side. This one, do you understand there's kind of a plus 0 here? So we start at 0. Negative x means negative 1. So down 1 over 1. Could keep doing that if I wanted to. It's or equal to, so that means it's solid. So again, less than or equal to, solid. Slope is negative 1, beginning at 0. And it's less than, so the bottom of this line is right there. Do you see how this one's going to get a little ugly? Y is less than 2, so put a dot at 2 on Y. It's dotted line. Less than is the bottom. Can you see where all 3 overlap? Nice little menagerie of colors. It's kind of like right here and then to the right of the orange. That's your answer. Anything in this little region is true for all 3. There's a whole bunch of regions here. Like this region right here is just green. This one's blue and green. But this region's all 3. And that's the solution. The last one's pretty easy. It's basically just asking which of these 3 points, if any, are in the double shaded region right here. It's kind of almost like a gimme question. You just look at it with negative 2, 4. Negative 2, 4. Is A in the double shaded region? Yeah. So that's an answer. Next one, 3, 1. Is that in the double shaded region? No. And the last one, 4, negative 3.
No.
Neither is that. These 2 are both not in the double shaded region. This is. So A is a solution. B is a solution for one of them. C is a solution for neither of them. But our goal is to see which comes in the double shaded region, which is right there.